This is question number 16. Methane react with bromine as shown in the following equation. We have methane, which is a gas, react with bromine, which is a gas, and what is formed is methyl bromine, which is a gas, and hydrogen bromide. So, using the bond energies in table 4, calculate the enthalpy change. This is the symbol that we use for the reaction. So we have table 4. So the bond, the energy required to break the carbon hydrogen bond is 412 kilojoules. We have carbon and we have carbon and bromine atom. We have 276. Bromine atom and bromine atom, to break them, you have 193, hydrogen and bromine. So to be able to do this, what we have here is we can use BBF, bond breaking energy, and we have bond forming energy. So these two, we will get the difference between the two. Now, if you look at the methane, we have this bond. So we have methane, we have a bond of hydrogen, 4 hydrogen, or that is a methane. Then we have we have Br and Br, that is Br and Br. Then we have, so that is for bond formation, the bond that are being formed. Then what we have here is methyl bromine. So we have, these are the bonds. We have as a bond of hydrogen, a bond of hydrogen, and a bond of bromine. And another one, which is H and bromine. So these are the bonds that exist. So to be able to get the enthalpy change, what we do, we calculate the energy used to break this bond. So we start here and say the bond of H and C. We have 4 of them here, 4 bonds. This one and this one. You have to you break the 4. So you say this is equals to the energy required to break this bond is 4 multiplied by 412, which will give you, you can use your calculator, you'll be able to get 1648 kilojoules. Then we have the bond of bromine. The energy required is 193. So Br, it's only one bond, so it's 1 times 193. So that does not change, it is 193. So that is the energy required. So we say total energy. You add the 2, so this will be 1, this will be 4, and this will be, this is 7, 8, and this is 1. 1,841 kilojoules. What about the other? This is a bond breaking energy. So we have bond forming energy, the energy that will be used on the other side of the reaction. So we have this one. What we have is C, or rather we start with H. We have the bond of hydrogen and carbon. How many are they? They are 4. 1, 2, 3. So they are 3. So we say it is 3 multiplied by 412. The bond requires to break that. When you multiply that, you get 1236 using your calculator. Then there is this bond. There is this bond of carbon, that is Br and carbon. That bond requires 276. So it's only 1, 276. We say it is 276, does not change. Then we have the bond of formation of the hydrogen bromide. So it is hydrogen hydrogen and bromide, which we have is 366. So it is 1 times 366, so which will give us 366. So you get the total of bond formation. Using your calculator, you get this is 8, you get this is 7, you get that is 1, not 1 but 8 and 1. So the difference, the change, enthalpy change, is a difference between the bond formation and the bond breaking. So what we do, change in enthalpy is equals to bond breaking energy minus bond formation energy. So this is equals to, the bond formation energy is 1841, and you minus bond breaking energy, it is 1878 kilojoules, which you get, it is minus 37 kilojoules per mole. So that is how you work out that. So very important to understand the bond breaking energy and bond forming energy. So that's how you answer that. You'll be able to get 3 marks.